So I'm Arvin Enriquez, your subject teacher. So in this video lesson, we're going to discuss random math problem from your Maxima and Minima under your differential calculus. So the given problem, so what value of x does a maximum of y is equal to x cubed minus 3x occur? So there is a given function here. So we're asked to find the maximum point, no, of this given function. So for the solution for this problem, so we're asked to find the value of your x, where the maximum of the given function occur. So for us to get the maximum or the value of x that will represent the maximum point, no, of the given function, then let's try to get the first derivative of the given function. So what will be the derivative of this given function, which is y is equal to x cubed minus 3x. So that will be the first step for us to identify or for us to find the maximum point, no, of the given function. So what will be the first derivative of the given function? Y is equal to x cubed minus 3x. Now here, y prime here, so that will be your derivative of your y. Y prime represents your slope, so that will be equal to your dy over dx. So simply, your y prime is the first derivative of your y, or the given function. Now, at the right side of your equation, so there's an x cubed minus 3x here. So what will be the derivative of this x cubed? So in reality, there's a numerical coefficient here which is equal to 1. So we just simply multiply this exponent to your given numerical coefficient under your first term at the right side of your equation, which is now equal to 3. That's why it's 3 here. No? Then we need to subtract 1 to your exponents. That's why it's 2. So the derivative of x cubed now is equal to 3x squared. Again, we just simply multiply your given exponent to your numerical coefficient for that term. Then we need to subtract 1 to your given exponent for that particular term, no? So that will be equal to 3x squared. Same process with your second term, which is 3x. So we copy your operation, that will be negative. So in reality, there's a 1 here as your exponent. So we just simply multiply this 1 to 3. So that will be 3 multiplied by 1 or simply equal to 3. Then we need to subtract 1 to your exponent. So that will be 1 minus 1. So x raised to 0 is equal to 1. Then we multiply it to 3. So that will be equal to 3. Then we apply your operation, which is your subtraction. Now, your y prime now, no, is equal to 3x squared minus 3. Then we always assume that your y prime or your first derivative is equal to 0. Now, for us to get the value of your x, no, we simply use this portion. Your 3x squared minus 3 is equal to 0. Now, so why we arrive with this one, no? So we just simply transfer this negative 3 to another side of your equation. That's why it's positive 3 in this one. So we just simply divide both sides of your equation by 3 for us to arrive with this simplified form of this equation. We just simply divide both sides of your equation. So 3x squared divided by 3, it's x squared. 3 divided by 3, that will be 1. Now, for us to get the value of your x square, I mean your x, no, we just simply taking the square root of your, we're just simply taking the square root of your entire equation. So what will be the square root now of your x squared? So that will be equal to x. So what will be the square root of 1? So that will be positive and negative 1. So here there are two computed values for your x. So that will be positive 1 and negative 1. So these values or these computed values of x will be substituted, no, to your second prime for us to get the maximum point. No. Now, what will be the second derivative of this one? So what will be the derivative of your first derivative or y prime? So your second derivative now or your y double prime is equal to what? So we just simply taking the derivative of your 3x squared minus 3. So 3 is a constant, so definitely that will be equal to 0. So your y double prime will be equal to the derivative now of your 3x squared. So we just simply multiply your 2 here, no, by 3. So that will be 6. Then we subtract 1 to your exponent, which is 2 minus 1. So that will be x. So still there is an exponent 1 here, so we don't need to write because it doesn't affect your value. Now, your second derivative now is equal to 6x. So we just simply substitute this positive 1, negative 1 to your second derivative, which is equal to 6x. So let's do this. So when x is positive 1, so what will be the value of your y double prime or your second derivative? So we just simply substitute this positive 1 to your x here, no? So your second derivative is equal to 6x. So simply your second derivative now is equal to 6 multiplied by 1. Then your second derivative is equal to your positive 6, which is greater than 0 in reality. So we consider this one as a minimum point. Why? Because when the second derivative is positive, no, since 6 is a positive number and the slope is equal to 0, since if we apply this one, positive 1, to your first derivative, once we substitute this positive 1 to your first derivative, it can provide it will provide you a value of y prime which is equal to 0. That's why if your uh, second derivative is equal to a positive value and your slope, which is your y prime, is equal to 0, once we substitute the computed x here, then the graph, no, or the transitioning of the concavity of this graph, no, is concave up, meaning to say your graph will represent a concave up. So meaning say this point here is the minimum point that your graph can meet. So meaning to say when your x is equal to 1, since your y double prime or your second derivative is a positive value and your slope is 0, then your graph concave up, meaning to say this point here, the maximum point that you can meet on this graph, no, is your minimum point because this will represent a negative part, no, of your graph once you graph in a Cartesian plane. So that will be a minimum point now. No, so the sign, no, I want you to take note of this, no. The sign of the second derivative tells us whether the slope of the tangent line to the given function, no, is increasing or decreasing. So meaning to say, if your if the value of your second derivative, no, is a positive value, then your graph is decreasing. Meaning to say it's concave up. That's why we consider this one, no, as your minimum point. And when your double prime is a negative value, it will represent a concave down. So that will be your maximum point now. That's why it tells us no whether the slope of the tangent line to the given function is increasing or decreasing. So in other words, no, the second derivative tells us the rate of change of the rate of change of the given function. That's why again no, when the second derivative is positive and the slope is 0, we get a local minimum point. That's why it will present a concave up, meaning say the maximum or your graph, no, or the function is decreasing. Now let's move forward, no, when your x is equal to -1. So same process, we just simply substitute no -1 as a value of your x in your second derivative. So y double prime is equal to 6 multiplied by -1. So the resulting value is -6. Now, when the second derivative is a negative value and your slope is equal to 0, it will represent a concave down. That's why if your double prime no is equal to a negative value, we consider this as a maximum point. So that's why no, if we're asked to find the value of x that will represent the maximum point, so that will be x is equal to -1. Why? Because if we substitute this -1 to your x in your second derivative, which is your y double prime, it can provide you a negative value. And once we substitute this -1 to your first derivative, it can provide you a 0 value of y prime. So that will be your slope. So just a while ago, no, I said that if your y double prime is a negative value and your slope is 0, then that value, no, is your maximum point. So therefore, no, your x now is equal to -1. So the value of x that will represent the maximum of the given function here, which is y is equal to 3x cubed minus 3x, is equal to -1. Again, because if we substitute this -1 to your second derivative and your first derivative, it can provide you a slope which is equal to 0, and it can provide you a second derivative which is uh, a negative value. Again, when the value of your second derivative is negative, your function is increasing. So meaning to say at some point here, no, we can meet your maximum point. And it will present a concave down. So unlike if your second derivative is a positive number, no, meaning to say that your graph or your function, no, is decreasing. Meaning to say that will at some point here when your function is decreasing, we can meet your minimum point. And it will present a concave up. So thanks for watching. If you want to like, comment, share, subscribe, so please do so. So I'm Arvin Enriquez, your subject teacher for differential calculus.